Hello everyone, welcome to my presentation. I am dealing with the course Power Plant Engineering. In that topic is types of nuclear reactors. The outline of my presentation is types of reactors and nuclear waste. In our previous lecture, I discussed about the pressurized gas reactor. So in this session, I start with the gas-cooled reactor. In gas-cooled reactor, uranium is used as a natural fuel. Uranium is used as a fuel, and the coolant used here is air, hydrogen, helium, and carbon dioxide. Corrosion problems are eliminated, and the coolant pressure is 7 bar, and the temperature is 336 degrees centigrade. And the moderator used in the gas-cooled reactor is graphite. If the helium is used instead of carbon dioxide for the leakage problems, the gas pressure would be less than 7 kg per centimeter square, so that the valve thickness should not have any problem. So in gas-cooled reactors, the gas is flowing through the channels round the elements, leaves the reactor at the top and flows through the heat exchanger by using the primary circuit, and this transfers the heat transfers the water into steam, and the steam is again which converts into the steam. The gas is recirculated with the help of the gas blowers. This steam drives the turbine. Means in this reactor, if the gases get heated, the hot gases is passed through the primary circuit. From the secondary circuit, the water coming from the turbine is sent into the heat exchanger. So by exchanging of the heat between the gas and hot gases and the water is get converted into the steam, and this steam is sent into the turbine, which drives to generate the electricity. Again, some of the condenser steam is sent into the cooling condenser. By using of cooling water, the steam is get converted into the water, and this steam is sent into the heat exchanger by using the condenser pipe. So this cycle gets repeated. In the primary circuit also, some of the hotter gas is heat exchanged, and the remaining heat gases is sent into the reactor. This cycle gets repeated. The two basic principles of gas-cooled reactors are high temperature gas-cooled reactors and advanced gas-cooled reactors. In high temperature gas-cooled reactor, the pressure ranges from 30 bars and the temperature is 800 degrees centigrade. In advanced gas-cooled reactor, the temperature is 648 degrees centigrade, and stainless steel cladding the fuel due to the high temperature. Stainless steel absorbs neutrons. Enriched fuel is used in the gas-cooled reactor. And next one is the boiling water reactor. The boiling water reactor enriched with the uranium consists of more fissionable isotope uranium-235. The naturally occurring percentage is 0.7%, which is used as a nuclear fuel, and the water is used as a coolant. Water enters into the reactor at the bottom. It takes up the heat generated by the fusion of the fuel and gets converted into the steam. So, in this, boiling water gets converted into the steam, and this steam is sent into the turbine. The steam directly turns the turbine, a generator, to produce the electricity. And some of the condenser steam is sent into the condenser. In the condenser, the steam temperature gets reduces and it's converted into the water. This cooling water is again sent into the reactor by using the feed pipe. And there is a bypass in which the water purifier is there, and again the process gets recirculated. And there is a recirculation pump here, two recirculation pumps which are used for the water for the recirculation. And the reactor core control rods are immersed for the control of the heat. This is the block diagram of the boiling water reactor. And advantages of the boiling water reactor are, as the steam is directly generated in the reactor, the thermal efficiency of the plant is higher than the vaporized water reactor. The capital cost is lower as the reactor vessel is designed to take low stresses, as the pressure in the vessel lower than the pressurized water reactor. For the requirements of the heat exchanger, pumps and auxiliary equipments are reduced or eliminated, and this results in the gain in thermal efficiency, which reduces the cost. The reactor is capable of meeting the fluctuations in the load requirements. And disadvantages are, there is a possibility of carryout of radioactivity to steam equipment. Therefore, the turbine also requires shielding. On the part of the load reaction, there are a lot of wastage of the steam, resulting in lowering of thermal efficiency. And more biological protection is needed, because in water some of the biological materials are there which makes the reactor corrosive. And next type of reactor is Candu reactor. Candu reactor full form is Canadian Deuterium Uranium Reactor. So CN stands for Canadium, DU stands for deuterium, and U stands for uranium. And it uses the heavy water. So what is meant by the heavy water? Heavy water means it is a type of water which is used for production of natural water. Natural water contains 0.015% of deuterium oxide, and which is about the 1 part of 6500. Deuterium oxide, that is heavy oxide, is prepared by using the two methods, distillation of water and steam by hydrogen exchange. In distillation of water, ordinary water is slightly lighter than the heavy water. For the steam hydrogen exchange, when hydrogen and steam is passed together in a gaseous phase over a catalyst, an interchange takes place whereby deuterium is concentrated in the water, and the byproduct here is hydrogen. So this is the introduction of the heavy water. And coming to Candu reactor, the natural uranium is used as a fuel. In the reactor is a steel cylinder containing of number of tubes which are subjected in the internal pressure. These tubes are also called as channels. So these pressurized tubes are called as channels, which are the coolant flow is opposite in the adjacent of flow. So the heavy water pass in this direction, and the coolant is passing in the opposite direction. In this reactor, the refueling is carried out where the reactor is operated, and the number of neutrons absorbs rod of cadmium are provided for control and protection of the reactor. The high temperature reactor leaves the reactor flow for the steam generation to produce the heat from the feed water, which is converted into the steam. This coolant then returns again by using the fuel exchange. As a basic difference between the heavy reactor and light water reactor is that The latter, the same water serves as both the moderator and coolant, whereas in the can-do reactor, the moderator and the coolant are kept separate. And the advantages are, since enriched fuel is not required, these reactors are more economical to those countries which does not produce enriched uranium, as natural uranium can be used as a fuel. Heavy water is used as a moderator, which has higher multiplication factor and lower fuel consumption. The period required for the construction is shorter than the pressurized water reactor and boiling water reactor. And this reactor do not have to withstand the high pressure like vessels of pressurized water reactor and boiling water reactor. Only the heavy water coolant circuit, that is the 5 tubes, has to be pressurized to allow the boiling water in the reaction core. Therefore, the cost of the vessel is very less. And disadvantages of the reactors are, the cost of the heavy water is very high. Heat exchangers must be leak proof, therefore results the higher than the initial cost. Very high standard of the design is needed, manufacture and maintenance is needed, because if one of the tubes is get any leakage, it should be replaced. The reactor size is very large, as power density is low when compared to the other reactors. Here, the reactor occupies a large volume of the space, and the disadvantages is the fuel charging machine is also here to charge the fuel. So this is the can-do reactor. And next one is the breeder reactor. In breeder reactor, the fuel used is uranium, that is enriched uranium. 15% of the fuel is mixed away of oxide of palladium and uranium. Small core of power density is high, and small vessels of chain reaction sustained by the fast moving neutrons. And the fertile material plus neutron is used as a fission reaction. And the coolant used is liquid metal, that is sodium. Handling of the sodium is very difficult because it has high radioactive metal. In this reactor, sodium is used as a radioactive, and there are two heat exchangers, primary heat exchanger and the secondary heat exchanger. From the reactor, the high temperature sodium is sent into the heat exchanger. For the exchanging of heat, another sodium non-reactive is sent into the heat exchanger, and there is an exchange of the heat between the high temperature sodium and low temperature non-radioactive sodiums. So this reduces the temperature of sodium, and again the low temperature is sent into the high pressure. So from the turbines, the cooling water is sent into the secondary circuit, and this increases the temperature of the water and gets converted into the steam, and this steam generates to the turbine, which generates the electricity. So there are three circuits: primary circuit, secondary circuit and steam circuit. There are two heat exchangers here. The advantages are high breeding gain is required and no moderator is required. High power density is required and low absorption of high water neutrons, as it permits high fuel burn up. And disadvantages are small core with the minimum areas are intensified with the heat transfer problems. The reactor needs enriched fuel. Neutron's flux is higher as the center of the core, and the liquid sodium is extremely corrosive. The handling of the sodium is the major problem because it is extremely hot and radioactive. So these are the types of the reactors which we discussed here.